Today we're going to talk about vector operations, things we can do with vectors. So let's say you walked from your house, you went directly east for 5 blocks, then turned and went directly south for 8 blocks. How far away from your house are you? And side note, it's not 13 blocks. Vector addition is like walking in different directions, but I end up with a straight distance from where I started. So for instance, if I have these two distances, if I start here, I'm walking my first distance, then I turn and walk a second distance. My total displacement is from the start of my first vector straight to the end of the second vector. This yellow line is what we're looking for in vector addition. When you're on a grid, you need to move vectors so that one begins where the other ends. When you're walking to a different place, you wouldn't go back to where you started before you change direction. So we're going to move one or the other of these two vectors so that one ends where the other begins. I can move the green vector, or I can move the purple vector. Either way, I will get the exact same answer. So I'm going to move the green one for now. Now that they're in the right position, I can make a third vector going from the start of my beginning vector to the end of my ending vector. That blue line is my total displacement, and we're going to call that the resultant vector. Okay? Super important word here, resultant vector. So let's take a look at this one. When I add these two vectors, again, I need to move one of them so that one begins where the other one ends. Then when I'm looking for my resultant vector, I'm going to start at the beginning of my first vector and end at the end of my second vector. When I add these two vectors together, that final purple vector is my answer. Notice that when I do that, I took a vector that was, we went -3 in the x direction, -2 in the y direction. I added it to this darker purple vector that went, let's say, +10 units in the x direction and 0 in the y direction. If you look at our final vector, its displacement went from -3 to +4, so it went in +7 in the x direction and -2 in the y direction. Take a look at the x and the y displacement in the first vector and in the second, and see if you can come up with how we got the third. If you can see that pattern, can you add these vectors without having a graph? What would 3, -4 be if I added it to 8, 6? The answer would end up being 11, 2. This would be our final resultant vector. -112 added to 9, 6 would give me 8, 18. And 6, 1 added to a vector 7, 0 would end up with 13, 1. Now let's take a look at multiplying vectors. Remember that multiplication is simply addition in disguise. Multiplying by 3 is the same as adding 3 of the same thing together. Like 2 times 3 is the same as 2 plus 2 plus 2. So if I want to multiply a vector by a scalar, I'm adding that vector to itself multiple times. So I'm going to multiply vector hj by 4. I need to make 3 more of those vectors. Remember, when I add vectors together, one ends where the other begins. So I'm going to move these so that they are end to end, or at least as close as I can get them. My final resultant vector goes from the beginning of my first vector to the end of my last vector. So notice, what was the displacement of our original vector? Hj had a displacement. We went positive 3 in the x direction and positive 3 in the y. When I multiplied that by 4, when I had 4 of those same vectors added together, I ended up with a final displacement of 12 in the positive direction and 12 in the y direction. What would happen if I wanted 2 of vector yk? Again, I need to make a copy so I can have 2 of them, if it'll stop moving. Let me make a copy, then I'll move it back. If I put one vector so that it begins where the other ends, notice that yk originally went -4 in the x direction and -4 in the y direction. When I had 2 of those being added together, I ended up going -8 in the x direction and -8 in the y direction. Negative multiplication is just slightly different. I'm still going to copy that same vector, but now instead of going in the same direction, that negative means I'm going in the opposite direction. So I'm going to need to turn this around. So now, instead of going 3, let's make sure, 3 in the positive x direction and 2 in the negative x, or y direction, right? So our original was 3, -2. When I turn these vectors around so that they're going the opposite direction, let's take a look at what happens. Oops, I turned it too far. So now my resultant vector is going from the beginning of my first negative vector to the end of my last negative vector. So where my original displacement was 3, -2, when I put -3 of those together, notice we went from 3 to -6. We went -9 in the x direction, and down here from -3 to +3, we went +6 in the y direction. So let's just do some quick practice. 5 of the vector 8, -2 is going to give me 40, -10. 7 of the vector -11, -4 will give me -77, -28. -3 of the vector 4, -1, remember that's going in the opposite direction, is going to give me negative 12 and positive 3. And finally, negative 1 of the vector 2, 5. That's only one vector going in the opposite direction. Gives me negative 2, negative 5. Let me know if you have any questions. Your assignment is in the workbook, pages 477 to 480. Good luck!